All right, so we're just gonna go over essentially a binary in Ghidra. There's 3 stages to this. So you have Trojan.bin, which then should lead you to another binary that you're trying to get, which will then lead you to the C2 server, which then also has a binary that you want to try to get. So the write-ups are in the training section next to where you got the binary from. But so to start, we're just gonna run Ghidra, get this booted up, close. We're going to do a new project, reverse. Verse training, and then it's Trojan. Alright, so we'll finish that, and then all I'm going to do here is I'm actually just going to take that bin file and drop it in here. So you'll see that it's an ELF file. It's x86, being compiled with GCC. And pretty much the destination for any of the Ghidra output will be here. So we'll click OK. It's going to import that file. We'll see some information about the binary here. Click OK. And then now we want to actually start analyzing. So we can double click on Trojan.bin. And then it'll pull this up and it'll ask us to analyze it. We'll say yes. You don't need a select all, just click analyze. And then you'll see down here that it's analyzing it, and now it's done. All right, so if we come to look, we have all of this assembly code here, which probably does not make sense to most of you, right? Anyone in here know assembly? No? So think of it this way. You have binary. So your ones and zeros, like this is a .bin binary file. Above that you'll have .asm, which is assembly. Okay? And then above that, by like one step, is C. Okay, so we're dealing with some pretty low level languages because we're taking a binary file and trying to work our way backwards. Okay, so I mean, if we wanted to see this in a light that's pretty close to what we're looking for, if I can find it here. It should be in here. Where is it? Oh, there we go. Open it. So this is what it looks like in hex, all right? So looking at a hex editor here, we can see, okay, so kind of translates it over for you. So in that first section here, those first 4 bytes is going to be your .elf. So that's your executable linked file, I think is what it is. Do you mind Googling that? Just double check. And that's just that extension that, you know, says, okay, you know, it's this type of executable. Right? I mean, a lot of this just looks like a bunch of jumble. You'll see, okay, cool.
Executable and linkable format.
Executable and linkable format?
Mm-hmm.
Okay. So it's executable linkable format. You'll see You have some stuff that deals with the compiler, and then just kind of going in here. This is just kind of all empty space, and then you'll get in here, which is just, it just looks like a bunch of a jumbled stuff, right? Like, okay, cool. Hey, look, here's some code that's coming out and showing. Like, these are specific strings that are in the program itself that are saved in its memory. Okay, so what we can do is we can actually pull this over and expand functions, and we can kind of see the different types of functions we have over here. You'll see all these random things like x86.getPCThunk. Those are all just memory function calls that deal with the compiler. Okay. So what you're looking for is typically your .start is like the start of your assembly file, but because this program was more than likely written in C to begin with, you want to find something that's like main, right? It's like, okay, cool. So we have a main function here, right? And we can kind of see it defines some things, and then you can see that it starts in this, call. It's pulling some stuff over from memory in the actual memory addresses here. Move, push, subtract, call the get login function, call the string compare. So those are hints that you're going to see that, okay, this was automatically written in C, because those are C functions. And the nice thing about assembly is you can go back and forth between C and assembly. So I'm not going to get too in detail with it, but you can call assembly functions from C and you can call C functions from assembly. You just have to actually wire it together, right? Okay.
So question for the assembly tree that I see on the side.
Yeah.
Is that more like the block programming of what's going on, and then when you pull up?
For here?
No, on the left side there.
Oh, I'll get to that in a second, because that's the nice thing about Ghidra. I'm just starting you off on, we're working our way up.
Gotcha.
Right? So, like when I said I was going to get to that in a second. Ghidra is kind enough to decompile things for us. All right. So cool. We have a function called main. We'll see it has this variable here that calls the get login function, and we have this one, string compare, and it's going to check to see if that login is root. Okay, so that's something to keep note of. So if var2 is not equal to 0, basically if they're not equal, then user check failed, exit the program. Then we're going to check the host name. Local 50 is just a variable, and 40 is the decimal number 64. Okay, so I mean it's just throwing that into this get hostname function. If we want to, we can actually double click on it, and we can see that Ghidra just couldn't figure out how to put it together. Okay.
So with the if I variable 2 is not equal to 0, user check failed.
Yeah.
So I get the exclamation point and then equal sign if it's not equal to, but if it's looking for an input, then wouldn't all inputs be like user check failed?
Yeah, so that's what the get login is for, is it's trying to pull over some sort of login or check that.
But yeah, because I'm just trying to think, what is it checking against?
So that's what the string compare is. So it's checking PC var should return a string,
Gotcha. And that
and it should be equal to root,
right.
right? So then we come here, we're doing the same thing, string compare, target PC.
So local 50 should try and be target PC. Wait.
No, wait, yes. When we get down here.
Alright.
So, like, okay, so it's just checking to see if you're root, and if you are target PC. Okay, that's just it. And then it's gonna set PC var to get login, which that would be root, right? And then we're actually going to take this variable here and bring it over. So local 50 will actually be target PC.
Okay.
So sprintf is just print this out. And essentially what we're printing out is wget, you know, the implant.bin from this address. And if you know anything about programming, %s is a placeholder for a string, right? So we have our two variables done here. We have root and target PC, right? So the address is http root tech targetpc.hostbin.org/implant.bin. And then we can see that it's changing that to be executable, and then it runs it.
Right.
Okay? And then because it's storing it in 150, because that's what it's doing here by having that in the front, is it's printing it to this to be ran in its system. That's all it's saying. So we know essentially what we're trying to get from this address. Do we want to run it? No. Our goal is to actually try to get that binary. So we can go Chrome. I'm not going to do Chrome. We're going to make this a little bit more technical. Terminal. Okay, cool. So I'm just going to desktop, make directory, Rev training. And that is how I keep ransomware from getting on my computer.
Nice.
Yep. All right, so wget, right, because we're going to download this. http://root tech target PC. Oh. .hostbin.org /implant.bin. So we can see we pulled that over. Yes, I want to trust the application, and we can see that we now pulled that down into desktop, right? I can't believe I did that. Okay, there we go. Now we can see that it's in there, right? I mean, if you want to, we can say, hey, let's look at it. We're gonna get nothing out of it. All right. So now that we know that's in there, we want to actually go and look at that one. So file, close, don't save because I've already done this once. Come back here, new project, next, and actually we're just going to navigate desktop. Because this is the implant binary, right? And then, where did I put it? Like I said before, just gonna take this and drag it on in. Okay, cool. So this one will actually be a little trickier.
So you got this from the Trojan.bin?
I got that from Trojan.bin. So I got the URL address, and because it's hosted on a server, I can use wget to pull it down onto my machine.
Gotcha.
Yep. Analyze it like we did before. Of course, it's just kind of like before, it's just a jumble, right? But if we come over to functions, we got all these fancy functions, but we're more interested in what main does, right? Yeah. So we've already seen it do this before, right? Where username comes back, but we don't know what username is, right? But essentially, SSH pass is a way to script out using SSH, and then essentially, like when you script it out, it can run commands onto that server. So pretty much you're passing it the password, the user, the URL, and what commands you want to run. So they want to run that c2.bin binary and check-in, right? Okay, cool. So they're running this with the argument check-in, but obviously this target is running something on port 22 SSH, right? So what we can do is we can look at it. All right, so there's a local variable 110, okay. Undefined pointer, and then it gives that, some sort of address space, but that's not used anywhere. Like, all right, so we have these build user and build pass functions. So let's go look at build user. So build user, it declares username, which we saw username in the other one, right? It declares that for a set memory of 13 bytes, and then it's going to start building it, right? 65, which is a character A, Z, U, come on, highlight, R,
Do you just know the
E.
hexadecimal numbers? Or?
No, it's popping it up, see?
Right.
D,
Oh,
yeah.
I should
No, I'm that good. No, the best thing I can teach you is to let the tools do the work for you. If you really wanted to, you could put this in like CyberChef, right? I, A, come on, M, O, N, D, and this is new line, or null character. My bad, not new line, null character. 10 is new line. So that spells out what?
I wasn't keeping track.
Can you just copy it and just run it and have it print out all the text?
Yes, you can. So that is what I was going to get to next. So instead of doing all of this, right, this is kind of complicated, cumbersome, whatever. We can actually take this and them.
Oh, here we go. It's using Vim.
All right, cool. So I include standard in standard IO, and that's my grandfather. But now, oh shoot, did I not copy it? No, I did not. Copy. Oh, shoot. I keep looking at the wrong thing because it's bigger on the... No, you know, my grandfather loves me.
That's awesome.
Yep. So, glad we got that out of the way. So, this is wrong. And it's already going to yell at us for it. It needs to be char. And this here is going to be main. And this is going to be int. So essentially all I'm doing is just going through here. And then what we're going to do is just printf user name. And that I think should be good. I can't think of anything else that might need.
What does malloc mean?
Memory allocation. Yep. That maybe. So :x, right click, GCC. We want the output file to be build user.c. Oh,
Didn't seem like it liked malloc.
no. I'm trying to remember what I did. Undeclared username is char. Oh.
You put here.
See if that fixes it.
The asterisk being for username.
What's that?
The asterisk in front of username.
That's so that's like accessing the value held at a memory location.
Why are you using that as the first line?
Why?
Yeah.
Because I'm first allocating the memory in that location. Because it's such a low-level language, you have to allocate the memory first. Yep. I'm gonna cheat a bit here.
How easy is it to cause like a buffer overflow or something?
Quite. You just got to put in enough information. Basically, if it's using like an unsafe function, which C is known for having plenty, then it'll do that.
Back to light mode.
Char standard lib. Oh, there's that. That's fine. That's fine. STD lib maybe. Yeah, I know. I'm cheating at my own. But it's better than sitting here watching me like suffer. So I %s. Whoop. That's gonna be in there. So it prints out the username. Just anybody remember if I had an asterisk next to here?
You did.
I did.
I don't know why I remember that one very specific detail, but I know I looked at it.
I love that it just doesn't open. Okay, yeah. Now that should work. Hopefully. I really need to turn that off. Okay, yeah, it built. And then we need to give it executable permissions, build user, right? And then we can actually run build user. So Azure Diamond is our username. Alright, so now that we know what this is, we can come back. Okay, what's the password? Yeah, that one I'm not going to be able to tell you or figure out. So I can't do the magic hovering trick. So this one will need to be built. Okay.
And you just go through the same process of
Yep. So I'm going to do that right now anyways. So we're going to go vim build pass.c. All right, insert we're going to include those two again. And I'm just actually going to paste this in here. Print f %s. All right. Comma password. And we know that this here needs to be a char, which is a pointer. That's going to be okay. That should be fine. And then, yeah. Build, pass. All right. So if we look through it, pretty much this is what I had in the example. Standard IO, standard libraries. We just kept this all the same. Switched the chars around, right? So that way it prints out nicely. And then I forgot to return afterwards. So I'm actually just going to change this. Okay, cool. So ch mod plus x build pass, right? We can see build passes in there. We should now be able to run build pass. And the password is hunter2.
So it's Hunter 2, not Hunter 2%?
Yeah. Because I forgot to put a new line.
Gotcha.
Yep. That is why that is there. So essentially what it's doing is it's just reading that, which is a null character.
What was the username?
Azure Diamond.
Oh.
Password is Hunter 2.
Password is hunter2. Right? So we know that, right?
Now what do we do?
Well, we're going to go back and look at this. Alright, so what we can do is open up terminal. And I'm actually just going to make her a tad bit smaller there. SSH. Azure Diamond at root dot target pc dot host bin dot org hunter 2.
Oh,
I spelled diamond wrong.
yeah.
That's right, right?
Yep.
Okay.
Round 2.
Round 2 of let's try this again. Apparently it's my bedtime.
Oh, that's sick. Hell
That's
yeah.
dope.
So now we're in, right? We're into the C2 server. Who am I? Right, Azure Diamond. All right, cool. Print working directory. We're in the users folder. Well, what's in the users folder? So let's look at the log. Implant checked in. Okay, cool. What about secrets? Permission denied. Okay, well, what if I want to look at C2.bin, right? No. What if we try to run C2.bin? Okay, it needs some sort of input, right? Well, now comes the more interesting part.
Is that the source for that CT.bin right there?
No, we're gonna pull this over SSH. I just need to remember.
Then you just do SFTP over 422 or whatever.
Yeah. I hate when it does that. Adobe. Because I don't remember the command off the top of my head. SCP. That is so nerdy. That was nerdy beyond all unreasonable doubt.
I apologize.
Wait, what? You do SCP over 422? What?
Yeah, so it's you mind looking it up? Because
I secure
I
copies, okay, so
yeah.
what do you mean by
What the actual name is of that. Oh wait, shoot.
that? SCP?
I need to exit out of that.
Secure copy.
Azure Diamond at root dash target
That's secret copy.
PC dot Of course I don't remember it. Hostman.org. Slash c2.bin, and I want it in this directory.
When do you need the password to?
Oh, because it thinks that you're in the root directory or something, right?
Oh, no. I see what I did. That's my bad. So what it is because that's the connection log. In the directory that you're coming into, you need a colon.
You're trying to SCP into that specific file.
Yeah. And then so we got c2.bin, and then it's just period. Period is this directory.
Why won't you need to put in? Oh.
Why don't you just do SCP?
And then now we have it.
Why don't you do colon asterisk? Does that work?
Colon asterisk.
Yeah, copy everything.
That is a thought.
Just create a new directory and try. The rest of them they could be missing.
Or we follow through. Well, now I'm running 2 instances of Ghidra. Look at that. Close. I hate this projector with a passion. I don't know why it's so hard to... Damn it. Wait, can I... No. Okay. Ghidra it is. That's the only way I'm getting that to open.
Reverse engineering C2 by hand.
Yep. That's the next thing we're going to do. Close. File. New project. Non-shared. Verse training. C2. And then we already know. Finder. Where's my desktop? I'm such an organized person. Don't you just love this? I know this bothers somebody.
Well, that's just go back to the terminal and type PWD, and that's where it is. Or just do that.
Okay. Cool. Bring the file over. Open it up. Funny part is I'm like speed running this. This took me a couple hours to figure out for the assignment.
This is considered like an easy assignment. You do this with the kit.
Well, I did this for my college course like last week. This was an assignment I had 2 weeks ago.
So this is actually like.
Yeah, this
not
is
an easy one.
this is in my reverse engineering class. This was bonus points, and it was for fun. So I'm like, hey, why not teach it to y'all?
I appreciate it.
So you're currently enrolled in the class?
Yeah. So this is what's called static analysis. I forgot to tell you that. Because the code is already in there. Dynamic analysis, you have to pretty much put it in a debugger, because as it runs, it's going to write the extra code in memory for it to run that way.
Right.
That is currently what I've been doing this week.
So is Beaver both a disassembler and a decompiler?
Yes. I guess you could say it takes its best guess at stuff.
Right.
IDA, like, for as much as I love Ghidra, and what you can do with it. IDO's better, but I'm not going to pay $3,000 for an IDO license.
For a year or something?
I forgot what it was. There's something we were going to do, and it cost us $3,000 for an IDO license. But I mean, you can do quite a few of the same things.
Suppose though, if you're chunking through that much code,
Display function graph, right? Like everybody's familiar with the beautiful function graph that IDA puts together. Ghidra does the same thing. A lot uglier, but it does it the same thing, and it's free. So you pay for what you get.
What is a Ghidra licensed under? Can you just apply and read its review?
looks like it.
Something like that. I really don't know. It's an NSA tool that got open sourced.
Yeah.
So either they have something better, or yeah. But so looking at our main function, right? We have all these, okay, this is what we got back, right? So apparently we need some sort of input. If there's no input, right, no parameter that's inputted, invalid invocation, right? So we have this other one. Okay, here we see that we have another string compare. It's checking parameter 4, plus 4 bytes, I think that's what it's trying to say. To see if it's checking, right? So we know that has to be one of the strings to use, check in. And we can see, oh, hey, there's that log file. We're opening the log file in write. So if you know what an F open is, file IO. So file open, the file we're opening, and what are we doing? We can only write to it. So you can do read write and binary. No, it's RWB, I think, are the three. It's been a few years since I took C. And write. So F write. So we're writing to the file, along with adding a new line character, implant checked in. Okay, that's what we saw, right? And then we're closing it. Okay, cool. But what happens if we don't use that? Well, now we're going to check to see if it's admin, right? Okay, cool. So admin has to be some sort of variable we can put in there. Oh, it's asking for a username. It's printing this out, and then it's printing out password. But it's also using scanf, and it's pulling it from whatever this is. I'm not going to follow that, to that variable, and pulling the password to this variable, right? Scanf, pulling it to local 94 and local 54. So we keep going through it. All right, ivar equals string compare, local 54 must be equal to hacker, right? And all right, cool. So if that equals hacker, we're gonna run this. I heart reverse engineering. Otherwise, invalid option, right? Like, oh, that's kind of cool. That's basically what all this C program is. But then it goes to menu. Okay, what's menu? Right? So once we get past that, we have this menu that we gotta go through and.
I really do appreciate.
Yep,
the
you're good. It'll be all on video. All right, so welcome admin. Enter a command number 1 through 100,000. Right, so we're scanning that to this local 10, and we're basically checking. Okay, if it's this 100,000, return. If it's less than 100,000, break. Other than that, command not implemented. And this right here is where you can see that example of assembly code, because that is a label in assembly. So, okay, cool. 0x45. Who knows what 0x45 is? Why would we print out nice? In decimal? It's 69.
Nice.
Yep.
Literally.
Okay, well then we got this one here. So if it equals this, go to this, and then basically we're gonna run cat on secrets.txt.
Gotcha. So that was the text we couldn't get to.
Yeah, so okay. Well, what hex is this? Well, thankfully by hovering,
That's 17.
31337 or elite.
Oh.
ELEET. Okay?
Gotcha.
Yep. So now what we can do is come back to terminal and we go back to our SSH hunter 2. Alright, ls /c2.bin, and we needed to input admin, right?
Yes.
Okay. Hack. I think it was that.
Yep, that's exactly right.
And then
Heart engineer.
heart RE. Alright, cool.
Come admin.
So what was our command? Elite.
Oh. Go to launch the new gaze. That's hilarious.
Yeah. So essentially you go from reversing the malware
That's super cool.
to bringing it back over to
Gotcha.
actually
So I can actually walk through this as soon
hacking
as,
back through it. Yeah.
I can walk through this as soon as I get Kira.
Yeah.
Ghidra up and running. That's pretty neat.
Yeah. So that is
Cool. Super cool.
that is going to